Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ukobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 2. It says the letters A to E in the table below represent 6 organic compounds. So they were just supposed to be 5 because that's 1, 2, 3, 4, 5. So they were supposed to say 5. Okay. Then let's proceed. We have butane. Now we know the strategy is to first identify the homologous series to which each compound belongs. So we have butane. It belongs in the alkane homologous series. And then here, we've already identified that when we see something like this is a triple bond. So this is an alkyne. This belongs in the alkyne homologous series. And then because we have the halogens here, we know that this is a haloalkane. And then D here, because of the double bond oxygen that is in between other carbon atoms, we know that this is a ketone. So we see a carbonyl group there. Then butanoic acid belongs in the carboxylic acid homologous series. Okay, so now that we've identified all that, let's answer the questions. Now 2.1.1 says a compound with the general formula CnH2n minus 2, right? So we know that that one is an alkyne, so we should indicate letter B. Now, which one is a ketone? We should indicate letter D. So when you have identified, when you have analyzed, it becomes very easy to answer. 2.1.3, a compound that can be used as fuel. We know that it is obviously it has to be the alkane because these are the ones that have a higher vapor pressure. Then that's A. 2.1.4, an unsaturated hydrocarbon. Unsaturated hydrocarbon. We know that it obviously has to be B once again because it has triple bonds, right? And then, okay, now let's look at 2.2. For compound E, write down the name of the functional group. Compound E is carboxylic acid, and the name of the functional group for carboxylic acid is carboxyl group, right? And then now they're saying 2.2.2 structural formula of its functional isomer. We know that the functional isomer to the carboxylic acid is an ester, right? So how do we draw the structural formula of the functional isomer? We have butanoic acid, so we should maintain that whatever structure that we draw must have 4 carbon atoms. So but means 4. So we can choose to draw. So either one of the structures would be correct if I draw ethyl ethanoate. So this is ethyl ethanoate. Remember, I have the divisor here for the ester, separating the alcohol and the carboxylic acid. Then I have it like that. And then 1, 2, 3, 4. So this here can be a functional isomer of the butanoic acid, or I can have this structure here. So as long as I maintain that there are 4 carbon atoms. So divisor, and then I have this. So also 1, 2, 3, 4. This can also be an acceptable structure. And then also again, still maintaining that I will only have 4 carbons. This can be a possible solution. This can also be another possible solution. So I have number 1, this is ethyl ethanoate. And then what I have here is propyl methanoate, or I can have methyl propanoate. So either one of these three can be possible solutions to that, right? So I hope the memo gives all three like that. Then, okay, 2.3, write down the IUPAC name of compound C. The IUPAC name for compound C. Now, let's start numbering. If we say 1, 2, 3, 4, we can see that our chlorine is in the fourth carbon. But if we say 1, 2, 3, this is the one that causes the earliest disturbance. So we must start counting from this side here. So we maintain that this here will be our longest chain, obviously. Then this is 1, 2, 3, 4, 5, 6, 7, 8, which it wouldn't give us 8 if we were only considering the straight chain. 1, 2, 3, 4, 5, 6. So you see, then now this is 8. The longest chain has 8 carbons. So the name, the compound name, 2.3.1, will now be what? In number 3, we can see a chlorine, and then also in number 5, we see another chlorine. So let's indicate the positions. That's 3 and 5. Then dichloro, and then since it's 8 carbon atoms in the longest chain, that's dichlorooctane. So dichlorooctane. So that's the IUPAC name. 2.3.2 says compound D. Write down the IUPAC name for compound D. Now, compound D, we can see that it is a ketone. And then this is the smallest ketone that we can actually have. Remember, your ketones, they start from 3 carbons, because remember, we must always have the double bond oxygen in between other 2 carbon atoms, right? So this is what is propanone. So you are not supposed to say this is propan 2O, because this is the smallest smallest ketone that you can have. So you just name it propanone. So there was a catch in that name. That 2 mark was not just for free. There was a catch. If you had written propan 2 on, then they would mark you wrong. Then 2.4, write down the IUPAC name of the functional isomer of D. Functional isomer of D. Now we should write the IUPAC name. Now the functional isomer for a ketone, we know that it is an aldehyde. According to Cake, we know that functional isomer of carboxylic acid is ester. Functional isomer of aldehyde is ketone. So ketone to aldehyde. If we write the IUPAC name of the functional isomer, this obviously has to be propanal. Remember, with the aldehyde, no indication of the position of the functional group, because it will always be on the first carbon. Then 2.5, write down the structural formula of the chain isomer of compound A. Chain isomer of compound A. So we should write down the what? Structural formula. Now butane has 4 carbon atoms. So all we should do to make it a chain isomer is just introduce a branch here. But then we maintain that the total number of carbon atoms will still be 4. Then just like that, we have created a chain isomer. So butane is a straight chain, but then 2 methyl propane. So okay, butane is a straight chain, but then 2 methyl propane is a branched chain. But then look at this, we still have the same molecular formula. So this is still C4H10. And then also for butane, it's C4H10. So same molecular formula, but different types of chain. Straight chain, branched chain. And then that was 2.5.1. Now, write down the structural formula of compound E, right? The structural formula for compound E, which is butanoic acid. So how should we draw that one? This is how you do it. Butanoic acid, that's 1, 2, 3, 4. So but 4. And then since it's a carboxylic acid, we indicate our carboxyl group like this. And then we just go ahead and fill in the hydrogen atoms. Fill in the hydrogen atoms. And then just like that, we have our structure for compound E, structural formula for compound E. And with all that being done, we have came to the end of the lesson. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.